In the world of cybersecurity, we've made this incredible leap. We've gone from just collecting evidence after a crime to actually predicting crimes before they even happen. This is the story of how our relationship with data had to completely change, transforming from, a passive library of facts into an active, intelligent detective. So let's dive into how this massive shift happened.
All right, here's our game plan. We're going to start by looking at the old world of data, figure out exactly why it failed, and then explore the huge shift to a smarter approach. We'll peek inside the AI toolkit, map out the whole intelligence pipeline, and then wrap up by looking at the challenges that are shaping the future of cyber defense.
So, to really get where we are now, we absolutely have to understand where we came from. See, the way we used to handle data was fundamentally different, and that distinction is, it's everything.
Okay, now this analogy right here is the key to the whole thing. Think of old databases as a perfect librarian. If you ask for a specific book, like, hey, show me all the user logins from yesterday, it'll find it for you in a snap. But a librarian can't read every single book in the library and then tell you there's a hidden plot connecting 3 of them. That's a detective's job, right? Data mining doesn't just retrieve facts. It investigates them to find those hidden patterns.
And this shift from librarian to detective didn't just happen overnight. For decades, databases were really just for storage. But by the 90s, the amount of data we had was just exploding, and we realized asking simple questions wasn't going to cut it anymore. And that brings us to today, an era where we use machine learning to make sense of these massive, chaotic streams of data coming from every corner of our digital lives. We're turning all that noise into real, actionable intelligence.
So what was the breaking point? Why did that perfectly good librarian model suddenly become, useless for security? It really came down to 2 major crises that created a problem the old tools just could not solve.
Let's really dig into the twin challenges that completely changed the game and basically forced the entire field of security to evolve or get totally overwhelmed.
First, it was the sheer volume of data. We're talking terabytes of logs every single day. There's no way any team of humans could ever review all of that. And second, the attackers got a whole lot smarter. They started using AI themselves, creating stealthy malware that had no known signature. The old method of just looking for known threats, it was like trying to catch a ghost with a butterfly net. It just wasn't going to work.
So with the old system totally broken, security needed a new hero, and that hero was the detective. This whole process we call data mining, which is all powered by artificial intelligence.
So what exactly is data mining? Forget the textbook definition for a second. It's basically about using automated systems to sift through those mountains of data and discover patterns that are interesting, new, and actually useful. The key is, it's not about finding what you already know to look for. It's about finding the stuff you didn't even know existed. And this quote just hits the nail on the head. A database can tell you, sure, a user account logged in from a strange location. That's what happened. But data mining, it connects that one login to 3 other subtle kind of weird events and tells you this is why it's suspicious, and by the way, here's what the attacker's probably going to do next. See the difference?
So here's the bottom line. We're moving from just collecting data to actually creating intelligence. Instead of drowning our security teams in millions of meaningless alerts, this approach gives them a prioritized, clear picture of the real threats they need to act on, like right now.
Okay, so we know we need a detective, but how does this digital detective actually do its job? What are the tools and techniques it uses to uncover these hidden plots in the data?
Let's break these down. First up, anomaly detection. This is absolutely crucial for spotting brand new attacks that have never been seen before, what we call zero-day exploits. Then you have clustering. This helps by automatically grouping similar events together, like identifying thousands of different computers that are all secretly acting as a single botnet. Sequence mining is fascinating. It can actually understand the story of an attack. It sees the initial scan, then the exploit, and then the final data theft, all as one connected event. And finally, correlation ties it all together, winking all these little clues from different systems to reveal one big coordinated attack.
Now that we've seen the tools in the toolkit, let's see how they all fit into a complete system. This is the engine of modern cyber defense, a pipeline that turns raw, messy, noisy data into crystal clear intelligence.
It all starts with ingesting data from literally everywhere. Then it gets stored, and this is critical, it gets cleaned up and prepared in pre-processing. You can't find clues at a messy crime scene, right? Only then, in step 4, do we apply the AI and machine learning algorithms to do the actual detective work. And the final and most important step is delivering that insight as a clear, actionable alert to a human analyst who can then go and stop the threat.
But as powerful as this technology is, it is not a magic solution. The fight is far from over, and the road ahead, well, it presents its own very complex and very serious challenges.
The bad guys are always changing their methods, so the AI has to constantly learn and adapt. We call this concept drift. The quality of the data is also a huge deal. Bad data leads to bad conclusions, simple as that. And maybe most importantly, the human analysts have to trust the system. They need to understand why the AI flagged something, not just get a black box alert that says something's wrong. And all of this has to be done while respecting user privacy and navigating some seriously complex legal regulations.
So, here's the final thought to leave you with. We are now in an AI arms race. The attackers are using these exact same powerful tools to create more evasive, more dangerous threats. The question that is going to define the future of our digital security is this: can our defenders, our digital detectives, innovate and adapt fast enough to always stay one step ahead?